Hello everyone, and we are back, and this week we are going to be covering chapter 18. Just a quick review over what we're going to be covering over the next two weeks. This first week we are going to cover lessons 1 and 2. Lesson 1 is biomass and geothermal energy, and then lesson 2 is on hydropower and ocean energy. And then next week we will continue with chapter 18, which is renewable energy alternatives, with lesson 3 on solar and wind energy, and finishing up with lesson 4 on energy from hydrogen. All right, before we get started in with any material for the chapter, I just wanted to post this. This is in case you printed the PDF copy, just as a reminder that you are supposed to be following the lectures as well. These PowerPoints go out to you just so you have the notes in hand or easy access to it. Or if you have to do some of your work offline, you could print it, but you should not be just covering the PDF PowerPoint. You should also be logging into either directly to YouTube, of which then you would need to complete your checklist and have it signed by a parent so that I know that you are actually watching the videos, or completing the video through pearsonrealize.com, and then the website documents for me that you've completed the lesson, and then I can give you your full classwork participation points. So just a reminder of how that works. You complete it on Pearson. You do not need to submit your checklist, email checklist. If you do not complete your work through Pearson, I need some sort of documentation, which is our assignment checklist, checked by you, signed by your parent, and returned to me via email in order for you to get those classwork participation points. If you are completing your work on Pearson, remember you do not have to do double work, so you do not have to send me the checklist if you've completed all the work on Pearson. Just to cut a little extra work out for you guys. All right, so we are going to start with our central case. And our central case is discussing Germany's big bet on renewable energy, which is, of course, our topic for Chapter 18, renewable energy alternatives. So let's read through this. Germany, a nation of 82 million people, uses vast amounts of energy. Germans are betting on renewable sources of energy, wind, water, sunlight, and plant material, to supply their energy needs and cut down on greenhouse gas emissions. In the year 2000, Germany passed the Renewable Energy Law, which specified that the nation must obtain a minimum of 10% of its energy from renewable energy resources by the year 2020, which is where we are today. The law has had a wide impact. For example, it has meant that Germany must burn less coal, despite the nation's plentiful coal deposits. In addition, Germany is shutting down its nuclear power plants, even though they emit no greenhouse gases and once produced one quarter of the nation's electricity. In 2000, law specifies that electric utility companies must buy renewable electricity at a guaranteed high price from anyone who produces it. To sell renewable electricity, people have built windmills in cow pastures, and solar panels have appeared on homes and offices. Germany's policy has increased renewable energy and reduced greenhouse gas emissions. By 2008, 15% of Germany's electricity and 7% of its heating already came from renewable resources. That which to renewable energy reduced emissions of greenhouse gases by 105 million metric tons, and Germany's economy has benefited. Renewable energy industries have annual sales worth billions of dollars and provide jobs for more than 200,000 people. In spite of its success, however, Germany's policy has disadvantages. For example, energy prices have increased somewhat. In 2008, the average German household paid about €3, or about $4.50 more per month for electricity than they did in the year 2000. And there have been environmental costs. Most of Germany's renewable energy comes from windmills. Windmills are altering the landscape. They may be harming populations of birds and bats, causing other kinds of ecological damage. The German government has mainly promoted technologies that are economical to use right now. The government has placed less emphasis on research into new ways to produce renewable energy in the future. Some experts think that this will eventually slow down the growth of the renewable energy industry in Germany. That slowdown in turn could decrease the economic benefits that Germany has experienced. The problems are serious and no one knows what the future holds. So far, however, Germany's economy has remained strong, and Germany seems to be leading the way to the future in which people depend on clean, renewable energy resources. And on you'll see a little map, and Germany's highlighted in green. So, referring to the big question, what are the potential uses and limitations of renewable energy resources? So, we'll get into more of that as the chapter continues. So, let's summarize this case study that we just went over, or the central case. Germany's big bet on renewable energy. We saw that into the year 2000, Germany passed the Renewable Energy Law, which required that the nation get at least 10% of its energy from renewable resources by 2020. The policy has increased renewable energy, created jobs, and reduced greenhouse gas emissions. However, Germany hasn't invested heavily in new technologies. Most of its renewable energy comes from wind turbines, which can cause ecological damage. So we have to question ourselves, are solar panels and wind turbines practical ways to generate electricity in our community? Maybe we'll learn more about why or why not as we continue through chapter 18. Our guiding question for this section is, how can we use biomass energy and geothermal energy? So today, Monday, we'll be covering chapter 18.1. This lecture will continue into Tuesday as we finish up chapter 18.1. And by the end of these two lectures, you should be able to explain the benefits and current status of renewable energy resources. We should be able to define biomass energy and explain how it is used. And we need to be able to describe how geothermal energy is harnessed and used. I want you to go ahead and stop and complete your chapter 18.1 vocabulary, which is biomass energy, biofuel, biopower, geothermal energy, ground source heat pump. Renewable energy resources are sometimes called alternative energy resources because they are an alternative to fossil fuels and nuclear energy. Why is it important to provide an alternative? Fossil fuels will not last forever. In addition, there are causes of pollution, including greenhouse gas emissions. Nuclear power is relatively pollution-free for an alternative to fossil fuels, but it has its own problems, as we saw in the last chapter, which was including waste disposal and the possibility of large-scale accidents. So here we see on your screen some stalks of corn, and it says here our fact is agricultural waste, methane gas from landfills, and heat from the earth are just a few renewable energy resources that can help replace fossil fuels. So, we're going to talk about some reasons that we need alternative energy. You're probably familiar with some kinds of renewable energy already. When you see a sailboat gliding across the bay, you are observing wind energy in action. Since ancient times, people have harnessed wind and moving water to do work. Hundreds of years ago in Europe, America, and other parts of the world, windmills and water wheels turned machinery that ground grain into flour. And long before that, people burned wood to cook food and keep warm. Today, wind, water, and wood still provide people with energy. In addition, if you have seen solar panels on roofs, you know that people have found ways to capture energy from the sun. Scientists are looking into new ways of using renewable resources to fill modern energy needs. There are some benefits of renewable energy. Renewable energy resources provide several benefits, in fact. For one thing, most of them are unlikely to run out. Also, if renewable energy resources replace fossil fuels, they will help decrease the air pollution and greenhouse gas emissions. And if our nation develops renewable energy resources, we will be less dependent on other nations to supply us with fuel. Finally, the development of renewable energy will create jobs for people to design, build, and maintain the needed technology. Maybe you will be one day have a career in a renewable energy industry. Renewable energy today. Today, the world is powered mainly by fossil fuels. Oil, coal, and natural gas supply 80% of our energy. These three fuels are These three fuels also generate 2/3 of the world's electricity. However, use of renewable energy sources is generally growing much faster than the use of non-renewable energy. The leader in growth is wind power, which has grown nearly 50% each year since the 1970s. Renewable energy will probably keep growing rapidly. That will happen because the world's population will keep increasing, and along with it, the need for energy. In addition, reserves of fossil fuels are decreasing. Furthermore, citizens want cleaner environments. In spite of growth, though, it will take renewable energy resources some time to catch up. At present, even though renewable energy technology is rapidly improving, renewables cannot yet produce enough power to replace fossil fuels and nuclear energy. So taking a look at our graph, we can see it's titled Sources of Renewable Energy in the United States. So for our diagram A, pie chart, we have the U.S. consumption of renewable energy by resources, and we see that our key down here is hydropower, 36%, geothermal power, 5%, wind, 5%, solar, 1%, and biomass, 53%. B pie chart shows us the U.S. electricity generation from renewable resources. So here we see hydropower having a much larger 70.2%, geothermal down a little bit at 4.2%, wind energy increasing at 5%, solar decreasing down to 0.2%, and biomass significantly decreasing to 15.7%. So it asks us here, compare and contrast. About 7% of the energy in the United States comes from renewable sources. How does this compare with Germany's goal for 2020? Well, Germany's goal in 2020 was 10%. So the US is at 70% of that goal. Let's talk about biomass energy. Biomass is a material that makes up living organisms or comes from organisms. Wood, manure, and grain are all examples of biomass. Biomass energy is energy that is produced from this material. Recall that fossil fuels, too, come from living things. However, unlike energy from fossil fuels, biomass energy is renewable. So just to reiterate, what is biomass? It is actually materials such as wood, manure, and grain that is made up of living organisms or comes from living organisms. Biomass energy is also called biopower. It is produced by burning the biomass. So if you set on fire the wood, manure, or grain, you are generating biopower. Biomass energy can be used for heating, cooking, lighting, vehicle fuel, or electricity generation. In our image here, we see a front loader moving coal at the Dunkirk steam station in New York, which will soon be set up for conferring biomass. So using biomass as an energy source. There are many ways of using biomass to produce energy. More than 1 billion people still burn wood from trees as their main energy source. In developing nations, families gather wood to burn in their homes for heating, cooking, and lighting. Wood, charcoal, and manure account for 35% of energy used in developing nations. In the poorest nations, these forms of biomass supply up to 90% of energy. Industrialized nations are developing new ways to use biomass as a source of energy. Biomass energy can now power motor vehicles and generic electricity. So again, the biomass is the solids or items that can be used to burn for energy. So these again include wood, charcoal, manure, agricultural and timber waste, and something called switchgrass. And here we see a woman in Mozambique, Africa, collecting wood to use as fuel. There is something else called biofuels. Biofuels are liquid fuels from biomass sources, and they are helping to power millions of vehicles on today's roads. The two primary biofuels are ethanol, which is used in gasoline engines, and biodiesel, which runs diesel engines. Ethanol is produced by the fermentation of starches or sugars. The result of this type of fermentation is pure alcohol. Ethanol can be used either by itself or as a supplement to gasoline to power cars. The ethanol that is used as an energy source in the United States is produced mainly from corn. A blend of gasoline and alcohol called gasohol is widely used in the United States because it releases smaller amounts of pollutants, such as carbon monoxide and particulate matter that does pure gasoline. Also, biodiesel. Biodiesel is produced from vegetable oil, such as soybean oil. Although biodiesels can be used in its pure form, it is usually mixed with conventional petroleum-based diesel fuels. Biodiesel cuts down on emissions compared to conventional diesel oil. Now let's go ahead and take a look at our real data. Discussing biodiesel. The graph shows the percentage reductions in several major automotive pollutants when two kinds of diesel fuels are burned. One kind, B20, is a mixture that consists of 20% biodiesel and 80% conventional petroleum-based diesels. The other, B100, is 100% biodiesel. So let's take a look at our chart before we read the questions that they want us to answer. So, reducing pollution with biodiesel is our title. We're going to have our y-axis, which indicates the percent reduction compared to petroleum diesel. And then on our x-axis, we have the list of different types of fuels, it appears, which is carbon monoxide, particulate matter, carbon, total hydrocarbons, sulfates, and nitrogen oxides. Well, those are the list of pollutants that are released by the biodiesel on the x-axis. All right, so we have represented by our colors here, B20 versus B100, going to be the differences in all the green ones will be the B20, and we're going to be able to compare that to how many different pollutants were released compared to the B100 listed in purple. So number one, interpret graphs. In the graph, what do the percentages refer to? Hint, look at the label for the vertical axis and think about what both fuels are being compared to. So the percent reduction compared to petrodiesel. Our graph is showing us only biodiesel. So we have the percent that pollution is reduced compared to the pollution released by conventional petroleum-based diesel fuel. Number two, interpret graphs. If B20 is used, by what percentage are carbon monoxide emissions reduced? So, compared to petrodiesel, we would look at the carbon dioxide of the green B20 fuel, and we see that it is at 10%. Number three, compare and contrast. One of two fuels shown on the graph which reduces pollution most. Clearly, we see that as we increase on the scale, that actually means that there is an increase reduction compared to petrodiesel. So it's a little counterintuitive, but the higher up means the scale we get means the higher the reduction, which is kind of sounds backwards, right? But clearly we see that the purple has a higher reduction compared to the traditional petrodiesel. And number four, interpret graphs. Can you use this graph to determine the actual amount of each pollutant released when the fuels are burned? Explain your answer. So no, we cannot. The graph shows percentages compared to conventional petroleum-based diesel fuel. It does not show actual quantities. So we cannot actually determine the actual amounts because we are just given percentages, not a measurement, a measurable amount. So now let's take a look at biopower. So electricity that is generated by the combustion of biomass is called biopower. Many of the sources used for biopower are the waste products of existing industries or processes. For instance, the timber industry generates sawdust and other woody debris. Corn stalks, corn husk, and biomass waste from landfills can also be burned to generate electricity. Besides using water, we also grow crops to produce biopower. These crops include the fast-growing trees and grasses such as this grass known as switchgrass, which you see on the left side of your screen. I've also inserted a copy that's not in your textbook, a figure showing you all the different available resources that donate to biomass generation of energy. So we can see that we have leftovers from forestry and crops, just like we were discussing, talking about the sawdust or extra woody debris. There's also vegetation like the sawgrass or switchgrass that we just discussed in the picture over here. Sewage waste can actually be used to convert into energy. Municipal solid waste, that's like talking about burning the corn stalks or the corn husk. Animal residues like manure can be used to generate biomass, or industrial residues as well. So leftover stuff from factories and things like that. So the decomposition of biomass by microorganisms actually produces gas that can be used to generate electricity. The breakdown of waste in landfills produces methane. This landfill gas is being captured in many landfills and sold as fuel. Power plants that burn methane and other kinds of biomass operate similarly to those powered by fossil fuels. The combustion heats water, creating steam to turn turbines that powers generators. So this is now kind of a reoccurring theme on how we generate that electricity. So we're going to close up with Monday's lecture with discussing the benefits and cost of biomass energy. So because biomass is a valuable energy resource, the German government has established a research center to explore and promote its use. There are many benefits to biomass energy. For one thing, the carbon produced by the combustion of biomass is the same amount of carbon that was removed from the atmosphere by photosynthesis to make the biomass in the first place. Therefore, the combustion of biomass releases no net carbon into the atmosphere. Biomass energy can also benefit nations economically. Unlike oil and other fossil fuels, biomass is distributed worldwide. Therefore, it should help reduce many nations' dependence on imported fuels. But what are the costs? Biomass energy has disadvantages. Biofuel crops take up land that might be used for growing food or left in its natural condition. Deforestation, soil erosion, and desertification can result if wood is cut down too rapidly for fuel. In reality, biomass is not renewable. If it is not used up faster than it, or if it is used up faster than it can be reproduced. Biomass is not an efficient source of energy, and its use can cause indoor air pollution. So there's inefficiency. There's growing corn for ethanol requires a substantial input of energy, particularly because farmers use fossil fuels to run farm equipment. Corn ethanol provides only a small amount more energy than the energy needed to produce it. It takes 1 unit of input energy to gain 1.5 units of energy from ethanol. So it begs the question, is it worth it? What about the indoor air pollution? Indoor air pollution can result if wood or other biomass fuels are burned inside buildings. In developing nations, the burning of biomass indoors is a major threat to health. It increases the risk of respiratory system problems such as lung cancer and infections. So that completes Monday, chapter 18.1, the first part of it. Go ahead and complete your workbook for questions 1 through 6. Answer key will be provided in the email that is being sent out. Go ahead and take a break and come back tomorrow, or if you want to keep chugging along, we will continue with Tuesday's lecture. All right, everybody, hello and welcome back, either to just a continuation on or welcome back to our Tuesday lecture. We are going to start by looking at geothermal energy and how we harness that energy from the geothermal. All right, deep beneath the surface of Earth, high pressure combined with the breakdown of radioactive elements actually produces heat. This heat is called geothermal energy, which heats rocks below Earth's surface, sometimes melting them to form liquid rock called magma. In some places, heated rocks or magma in turn heat underground water. Hot water and steam may pour out beneath the ground to the surface as shown in the figure on your screen. Figure 4. Hot springs and geysers are the result of the geothermal energy. So we can see an eruption of the geyser, such as this one that we see from Yellowstone National Park. And they are, of course, a result of the explosive energy of geothermal energy exiting the surface. So let's take just a quick preview look at how geothermal energy works. So we actually have radioactive decay in the Earth's mantle produces this heat. So first we have cold water is going to be injected into the ground. So we are actually pumping cold water in. Then hot water is pumped up, and the heat of that hot water is used to produce steam. So we pump in the cold water, extract the hot water, and then that hot water is pumped over through these turbines, and the turbines then pass that along to the generators, and the generators create the electricity that we need to be sent out along the power lines. So let's talk about harnessing geothermal energy. Geothermal energy can be harnessed to produce electricity in 2 basic ways. In some cases, steam from geysers at the surface is used to supply energy. Usually, however, wells must be drilled down hundreds or thousands of meters toward heated rocks and water. For example, Germany does not have many locations where magma comes close to the surface. So in Germany, therefore, deep drilling is the main method of getting access to geothermal energy. So let's just look at this summary real quick before we go to the next slide. Underground heat generated by high pressure and breakdown of radioactive elements is where we get that heat. There's usually, we have to access that by drilling below the ground. Steam turns the turbines like we saw in the previous slide, and that generates the electricity that we so desperately want. It can be used directly by piping hot water from its source into homes and businesses, or groundwater sources can heat pumps that use naturally temperate soil a few feet underground to heat homes in the winter and cool them in the summer. So we're going to take a little bit closer look at that as well. So what about generating electricity? So figure 5 is going to help us take a look at this. It's going to show us how geothermal energy can be used to generate electricity. In the illustration, a geothermal power plant taps into steam below ground. The steam turns the blades of the turbine, which makes a generator produce electricity. After being used, the steam is often cooled and condenses into liquid water. The water is then returned to the aquifer from which it came. Some geothermal power plants actually create the steam that is used to generate electricity. Cold water from the surface is pumped deep underground, where it reaches heated rocks. Heat from the rocks converts the water to steam. The steam then rises to power the power plants, where it is turns the blades of the turbine, and then, of course, again, back to making its way to the generator to produce electricity. So we'll just go through this with our map here. Okay, so in some cases, we have magma heats the groundwater, and steam from the heated groundwater can be used to generate electricity. So we have the aquifer here. That water is, we have this magma very close to this aquifer, so it is heating this water. Wells tap the underground heated water or steam, and then the water comes up and goes into this turbine connected to a generator. The generator then produces the electricity, and then afterwards it goes through a cooling tower, and then it is steam that cools, condenses, and then the water just flows right back into the aquifer, and then it'll continue the cycle. Of course, we can also just use the heat directly. There are things called hot groundwater pumps, and we can access the hot groundwater directly to heat our homes, offices, or greenhouses. Hot water is just simply piped from its source into buildings. Therefore, heating this underground water is practical only where geothermal energy sources are nearby. So if you don't have access to an area where the aquifer is close to the magma, there's no heat, and so you wouldn't be able to use this method of geothermal energy. You would only be able to do so in those locations. But this is just a simple method of getting heat into your home or your building. Then we have ground source heat pumps. So this is just a little bit more sophisticated way using some machinery and some pump units. We have geothermal energy can be used even in areas without heated underground rocks. So how do we do that? Well, this is how. We have a ground source heat pump that takes advantage of the fact that the temperature of soil a few feet underground just stays about the same temperature all year, even though the air temperature changes from season to season. The steady underground temperature is what enables the ground source heat pump to work. So we see here that heating in the winter. In the winter, the soil deep underground is warmer than the air up at the surface. So water flowing through the pipes transfers heat from the ground to the house, and then it is able to warm the house, and heat is distributed into the system, into the house. On the other side, if we're wanting to cool the house during the summer, in the summer the soil underground is cooler than the hot beating sun in the summer outside, which means that as you pump water from the house that's being absorbed, the heat's being absorbed from the system up here, you pump the water down into the soil cools that air and then is able to be pumped back into the house. In a ground source heat pump, water circulates through the underground pipes as shown in our image here on either side. In the winter, the water picks up heat from the ground and transfers it to the building. The opposite happens in the summer, like we just discussed. Water transfers heat from the building to the ground, cooling the building in the process. More than 600,000 ground source heat pumps are already used to heat homes in the United States. So, what are some benefits and costs of geothermal energy? The use of geothermal energy can help replace the use of fossil fuels. Like other renewable resources or sources of energy, geothermal power causes far less air pollution than fossil fuels combustion. The geothermal power releases as much smaller quantity of greenhouse gases than do the burning of fossil fuels. On the negative side, geothermal sources may not always be truly sustainable. If a geothermal power plant uses heated water more quickly than the groundwater is replaced, the plant will inevitably run out of water. In addition, the water of many hot springs contains chemicals that damage equipment and add to pollution. Some geothermal energy projects may trigger earthquakes. Moreover, geothermal power plants are generally limited to areas where heated groundwater can be tapped fairly easily. Most of the world's nations, include Germany, have few such areas. All right, for classwork, you need to go ahead and stop here and finish up your workbook questions on Chapter 18.1. Don't forget to refer to your answer key in your email and post it on LMS. So go ahead and complete workbook questions 7 through 14. Sorry to not end there, but we do have our first of 2 homeworks this week, and so our homework, you can either access it on www.pearsonrealize.com and complete the Chapter 18.1 Assessment 1. Which is also posted here. So if you'd rather just answer it on a piece of paper and submit it via email, make sure that you go ahead and submit that as soon as possible. And I hope you guys have a wonderful evening, and I will see you back with tomorrow, Wednesday, and Thursday's lecture.